In this video, we're going to be learning about probability and certain probability rules. So probability, first off, is a measure of how likely an event is to occur. So an example of that would be something like today, there is a 60% chance that it will rain. Or you could say the probability of flipping a coin and getting tails is, you could either use it as a decimal, like 0.5, or you could say 50%. Now we have a few probability rules. So probability can be written as a fraction from 0 to 1, as a decimal from 0 to 1, or as a percent from 0% to 100%. So remember, if we have something like 0.47, we move the decimal place over 2 to the right. So we could say 47%. But if we have something, this is a mistake a lot of people make, if we have something like 0.7 or 0.6, I don't know why I said that and wrote something else, I still have to move it over 2 to the right. So remember, I could just add an extra 0 to the end. And now when I move it 2 to the right, it becomes 60%. So we have a few different examples. So one of these is certain to happen. So if there is something that is absolutely certain to happen, maybe like tomorrow is Tuesday, that's really, really certain, I can say that probability is 1, or I can say that is 100%. If I have something that's never going to happen, that would be 0 or 0%. If I have something that's equally likely to happen or not, that's going to be 0.5 or 50%. Now we have a few different types of notation. So our first is P of A, and this notation is the probability of the event A occurring. So I could have like the probability of some event, like I could write probability of tails. The probability of the event is the number of ways the event can occur all over the total number of outcomes. So we're going to see a few examples of this in a minute. An outcome is just a possible, we could say outcome or result of the probability experiment. This can be something really simple. Like a probability experiment could just be like pulling socks out of a drawer, rolling a dice, or it can be something that's really, really complicated, like the weather, where there's a bunch of different outcomes that you could have. And an event is a specific outcome or result of the probability experiment, whatever that happens to be. Now we have this other notation. So P of A raised to the C, so anytime you see something like in the exponent spot that's a C, it's the notation for the probability of all but A occurring. So, and this is called the complement, which is why we have a C. So the way sometimes we say this is just the probability of not A. So maybe I'm pulling socks out of a drawer and I have some red socks in there. but I also have like white and blue and purple and tie-dye, right? So if I'm wondering the probability of not red, everything but red, that would be the probability of pulling the blue or pulling the purple or pulling the tie-dye. All right, we have a few more words and then we'll get into some examples where this might make a little more sense. Now we have something called mutually exclusive, or we call this disjoint. So this is two events that cannot occur at the same time. So if I'm flipping a coin, heads and tails are mutually exclusive, or we call it disjoint, because I can't roll and get heads and tails on the same turn, right? Or if I'm pulling out one sock, I can't pull out a sock that's red and a sock that's white. Say they're all just one color, right? I could have a red and white sock, but that's besides the point. Another example would be on a certain day, it can't be both Tuesday and Friday, right? It's just one day. So those would be disjoint events. Now I have something else that's called independent. So one event is independent from the other, or one event does not affect the other event. So maybe you and your friend, if you didn't talk, didn't interact, the probability that one of you is going to eat breakfast is probably independent from the probability that the other eats breakfast. Might not be independent if you guys are in the same place, and then the event that one happens kind of influences the event that the other happens. Sometimes we have to test to see if two events are independent. So maybe I thought, I gave my Block 3 geometry a test, and I thought that their outcome was going to be independent of the scores of the next class. But maybe the next class did a little bit better if you guys shared some of the answers, right? Then they wouldn't be independent. But they might be independent if, say, you were in two separate locations, you didn't interact with each other. Next up, we have sample space. So the sample space is all of the possible outcomes. And we list these, like for something like flipping a coin, if I wanted the sample space, we could call it S. That's just heads or tails. Those are our two options. Rolling a die, my sample space is going to be one of 6 numbers, right? I can either get a 1, 2, 3, 4, 5, or 6. So now let's do a few examples. Let's say we have this spinner on the right with A, B, C, and D. What is the probability that the spinner will stop on part A? Well, the first thing I can say is there's only one real option that it stops on A out of 4 total options. So that goes back to what we talked about the probability of an event, the number of ways it can occur over the total number of outcomes. I can also plug that in my calculator, or I know that decimal is 0.25. Or remember, I can express it as probability or percent. So I move the decimal place 2 to the right, and I get 25%. Now it asks, what is the probability that the spinner will not stop on part A? So originally, I was asking for the probability of A. Now I'm asking for the probability of not A. Well, not A is B, C, or D. So the probability of not A is 3 out of 4, or 0.75, or 75%. Now let's take a look at this next problem. So we have another spinner. What is the probability that the spinner will stop on an even number? So the probability of even, in this case, if I have just 1, 2, and 3, that's really just the probability of 2. That only happens 1 out of 3 times, which is 0.33 repeating, or 33% about. The probability that the spinner will stop on an odd number is just probability of not even, or 1 or 3. So that's going to happen 2/3 of the time, which is 0.6 repeating, or 66%. Something really cool is that if you look at an event and its complement, they add to 1. So notice probability of A and probability of not A, 25 plus 75 add to 1, or 100%. Probability of even and probability of not even, they also add to 1. So that's just a pretty cool thing that happens with probability. Now we have the following marbles are in a bag. What is the probability of picking a blue one? So we need to find out how many blue ones we have. If we count them up, there's 6, and out of the total is 20. We can reduce this to 3/10, which is 0.3, or 30%. Remember, we can express this probability in any of these 3 ways. On a regular number cube, what is the probability of rolling an odd number? Well, if we think of the sample space, we've got 1, 2, 3, 4, 5, 6. That means that there are 3 out of 6 odd numbers, or 1/2 of them are odd, which is 0.5 or 50%. The probability of rolling a multiple of 3. Well, what are multiples of 3? Those are numbers when, like 3 times 1, 3 times 2. So we've got 3, 6. I could do 9, but I don't have it, so I only have 3 and 6. So that is 2 out of 6, which is 1/3, or 0.33 repeating, or 33%. And last up, what is the probability of rolling a number less than 2? The only number is less than 2, so the probability of less than 2 is the same thing as just the probability of rolling a 1. That only happens 1 out of 6 times, or 0.16 repeating, or 16.6 repeating percent.